Selfish method is how they call the method to make an Egyptian fraction. Now let's use 4 over 5 as an example. In selfish method, you should subtract the fraction with the fraction starting from 1 over 2, 1 over 3, 1 over 4, and so on. So, 4 over 5 could be subtracted by half, or 1 over 2. Then you will get 3 over 10. Keep on subtracting with the fraction that has a number of 1. But remember, you cannot have any number repeated like 1 over 2 twice. Like, for example, 3 over 10 subtracted by 1 over 2 again. You cannot do that. You should change the fraction number. So we should subtract it with 1 over 4. Why 1 over 4? Because if we put 1 over 3 here, the result will be a negative. And therefore, we put 4 to eliminate the negative number. That 3 over 10 subtracted by 1 over 4 equals to 1 over 20. So, since the numerator ends with a 1 over something, we should stop the Egyptian fraction, or the selfish method. So in conclusion, 4 over 5 in Egyptian fraction equals to 1 over 2 plus 1 over 4 plus 1 over 20. So if we add this all, 1 over 2 plus 1 over 4 plus 1 over 20, the result will be 4 over 5. So this is an Egyptian fraction for an example of 4 over 5. Task 1. We should find the Egyptian fraction for 9 over 11. 9 over 11 could be subtracted by 1 over 2, which equals to 7 over 22. Then, we subtract it with 1 over 4. Again, because 1 over 3 would make a result as a negative fraction. Then, 7 over 22 subtracted by 1 over 4 will equal to 3 over 44. 3 over 44. So, since this has an and with a 1 numerator above, we should keep on continuing the fraction. So we should subtract with 1 over 15. Just to make it simple, if you want to do a cross calculation or cross multiplication, 44 times 1 equals to 44. And 3 times 15 will make it 45. I mean, it will be bigger than this. So it will be a positive fraction later on. Just to make sure that it isn't a negative fraction. So the result is 1 over 660. In conclusion, 9 over 11 in Egyptian fraction is 1 over 2 plus 1 over 4 plus 1 over 15 plus 1 over 660. Task 1B. 9 over 11 equals to 1 over 2 plus 1 over 4 plus 1 over 20 plus 1 over k. So we should find k. So we should use the normal way of finding Egyptian fraction, but we should use this fraction, 1 over 2, 1 over 4, and 1 over 20. So 9 over 11 should be subtracted by 1 over 2, which equals to 7 over 22, subtracted by 1 over 4, equals to 3 over 44. Then, we should subtract 3 over 44 with 1 over 20. which as a result will be 1 over 55. So what it means is that k will be 1 over 45, because if we take this 1 over 2, 1 over 4, 1 over 20, then the last one ends with the 1 numerator above, so that for sure will be this one. For 55 will be k. So in conclusion, 9 over 11 equals to 1 over 2 plus 1 over 4 plus 1 over 20 plus 1 over 55. So that is task 1, part B. Task 1, part C. So 9 over 11 equals to 1 over 2 plus 1 over 5 plus 1 over A plus 1 over B. So now we know we should search for A and B. So we use normal Egyptian fraction, 9 over 11 subtracted by 1 over 2, which equals to 7 over 22, then subtracted by 1 over 5, which equals to 13 over 110, then subtracted by 1 over A, which we need to find A. So if we put example 1 over 6, 6 times 13 will be 78, and 78 hasn't exceed 110, so we could see that it will be a negative fraction. So we should change 6 into a number that will exceed 110. If we put 9 here, we can put 9 over here, but the result later on will be more than 1 plus 1 over A plus 1 over B. Then if we put 9 over here, it will be 1 over A plus 1 over B plus 1 over C. So the task asked us to do only 1 over A plus 1 over B. So 9 isn't A, so we should change 9. We could put 10 over here. So 13 over 110 subtracted by 1 over 10 will equals to 1 over 55. And the numerator above here, it's number 1, so we should stop the Egyptian fraction. Then we extract the number 1 over 2, 1 over 5, 1 over 10, and 1 over 55. So 9 over 11 will equals to 1 over 2 plus 1 over 5 plus 1 over 10 plus 1 over 55. So 10 will equals to A and B will equals to 55. So that's task 1, part C.